Actually, okay.
I was like, where are you?
Here's what you got. If your phone does not have a good app on it, let me know. I'll get you the exact angle. The angle needs to be up to the 10th of a degree. So you're going to have, here's your incline, boom. You can find your force parallel. How do you get your force parallel? FG sine theta. Are there any opposing forces?
The magnet force.
No, this is without the magnet.
Friction.
You're saying this is the friction of the surface, okay?
Okay.
The only thing acting on it is the gravity mafia. There is no frictional mafia at this point, okay? So it's only the gravity mafia that's trying to pull it down. So you can calculate that force parallel. That's your net force. You can take that, divide that by the mass, boom, there is a theoretical acceleration based upon that force parallel. Then you're going to determine an experimental acceleration without the magnet. But, you know, x equals 1/2 at squared plus v naught time. You're clever. What do you let the initial velocity equal?
0.
0. That goes away. Let that distance be 0.4 meters. Okay? Let that be 0.4
You
meters.
said start it from a certain place.
Yeah, I don't care where you start and stop. It
With
is
the two things.
because that's the length of the plates.
So let the start of it become be that.
Yeah.
The plates.
So wherever the plate is,
That's the start.
let that be. I don't know. In the lab, I tell you to let it be 0.5, and you go to 0.1. Okay. So then you're going to do that 5 times. Then you're going to get a second acceleration with the magnet in there. So what you're going to see is the magnet is going to produce an opposing force. So we'll pass this around. And what's technically known as an eddy current. So this is a pretty strong magnet. And if I drop it on the outside of this, okay,
Oh, doesn't it slow down inside?
Yes.
it falls like you would expect. Okay? But if I drop it on the inside,
It fell.
I'm making sure
You're,
they
you're,
were
like,
still.
you're like a magician, right? Like you're
What are
like
we doing,
you're like
bro?
using the force.
I'm making sure they were still.
Yeah, you're doing something.
I'm
Yeah.
Yeah.
You're a Jedi, bro.
We don't like.
That's so
You
cool.
know what I mean?
This is why Jedi.
so here's what's happening inside the tube. It's the same idea. So as this falls, right? As this falls, what's Mother Nature experiencing? A flux or a change in flux? Change in flux, right? So Mother Nature senses this change in the magnetic field. Mother Nature induces a current to oppose the change in the flux. Now, this thing falls slowly. So which direction is the flux point, or is the magnetic field pointing? Upward.
North to south.
Now, what if I flip it over?
Don't matter.
Doesn't matter.
Don't matter.
Why?
Is it's the same thing?
Same thing, okay? No matter what,
That's crazy.
it gets weirder.
No.
Oh, you had to say something.
No. Here's the cool thing. Because the inside of this is polished, this is cool. So I'll pass this around as you're doing the lab. Drop it, and then stand up over the top of it, and watch it, and you'll see, and you're like you're watching it fall in slow motion. Okay? And especially if it like tumbles at all, then you'll see it like it's being floating in between the walls and it's tumbling.
Oh.
So it's a bit of a psychedelic trip, just heads up. Okay? Just a heads up. But yeah, you stand up, drop that.
We're just gonna choose. So this is my
Gravity.
I think just watch it.
That's what my teacher told me.
Nothing small. Nothing.
Huh?
Yeah.
And then what it starts.
It's like gravity's a magnet.
Show me your
It's
picture.
what you're
Yeah. So if I do this,
No, not that one.
I had Hogan too.
Oh my God.
Gosh. When you get to question number 10, okay, let me give you a visual about what I tried to get happening on question number 10. Okay? You're standing behind what?
We don't.
So? What do you mean so? You're talking about everything.
Whiners.
Yes. I like they're gonna give us much fun.
You actually-
Right, Friday night is rocking out.
Okay. So on number 10, here's what I want you to see. You're standing behind the cart watching it go away from you. The left side of the magnet is the North Pole. So imagine here's your cart. Okay? You're like this. You're behind it. Here is the magnet. The left side is the North Pole of the magnet. Okay? Left side, North Pole. Santa's workshop is right here. Okay? Left side. So what I'm trying to get you to see here is that this is looking out on the plate itself. So the magnet's on the inside. This is your view of the outside of the plates. And what I did is that, again, we're assuming that you have like one little strand of wire. Like instead of a solid plate, imagine that's built up out of infinitely small numbers of wire. So what I want you to do here, so imagine this is this wire. You have X's or O's coming out of it. You decide, am I going to make more O's and am I going to make more X's? That arrow, that blue arrow, is not showing you the direction of the current. This is all that I'm wanting you to know is that's where I want you to draw the current. And it's either going to point up or it's going to point down. Okay? That's kind of the visual that I want you to see. So all I'm telling you is that that's where I want you to draw the current. That is not the direction of the current. Okay? Current's either going to point up, current's going to point down. That's what you want to think through. When you get to this last question, okay, promise you there's going to be a question like this on the test, okay, because it's one of the fundamental ideas of all of physics. So, plastic cart, this is just a wire, okay? This is just a wire. It is not a solid plate like this is. All it is a wire. But you're going, so on this one, the cart's moving through the magnetic field. You have X's. What's the magnetic field doing?
Into the page.
Into the page. So as that passes through, you're going to see more X's. What are you going to make more of? O's. O's. Keep that in mind. Okay, I'm done. You're on your own. Get your data. There's 3 functional seconds. At the end of the year, and I've broken a lot of stuff.
All right, Mike, is this 2 day or 1 day?
1 day. So I'll have this in the back. Drop it, watch it fall. It's
Oh, wait. That's not the camera.